Welcome back to another Algebra 2 lesson. Today we're going to be talking about equations and linear functions. So let's just jump right in. We've got our standards. The way that we can go about meeting these standards is to be able to write equations in standard form, slope-intercept form, and point-slope form. Given an equation, I want you to be able to manipulate those, identify the slope, identify a point on the line, maybe 2 points depending on the situation. And let's just jump right in and get started. Again, important to know and understand the vocabulary. I want you to make sure that you're writing these words down somewhere in your notes. I am making Quizlets to share with you so you can practice, but there will be a vocabulary test, so please make sure that you're looking over these words, that you're learning them, you're understanding them. You can pause the video and write the rest of these words down so that you have it. Okay, moving on. Linear equations in standard form. You may recall from Algebra 1 that standard form is in the form of ax plus by equals c, where a has to be greater than 0, and a and b are not both 0, and a and b and c are integers with a greatest common factor of 1. So let's look at this. What is my value of a here? My value of a is the 2. What is my value of b? It's that -7, not just a 7. We've got to include that sign with it. And my value of c is -3. Okay, so when I'm looking at this in standard form, I don't really know the slope or the y-intercept. I would have to manipulate my equation to figure that out. But the nice thing is when something's in standard form, I can immediately plug in a 0 for x, solve for y, and now I know my y-intercept. I can plug in a 0 for y and solve for x, and now I know my x-intercept. So that's the benefit of standard form. Let's look at some problems where we use standard form. It says to write linear equation in standard form. We've got y equals 2/5 x plus 14. We want that to be in standard form. I can see right now it's in slope-intercept form. I have the slope of the line in front of the x. I've got the y-intercept over here, therefore it's in slope-intercept form. So what we know is we need that x and y to be together on the same side. So I'm going to have to take that entire x term and move it to the other side of my equation. And I do that by subtracting it from both sides. To get rid of it from this side, I subtract the 2/5 x. And so then I have to come over here and subtract 2/5 so that my equations stay balanced. So 2/5 x, take away 2/5 x is gone on this side, and I'm just left with the 14. And then when I do it over here, now I have -2/5 x plus y. Okay, so the problem is that I don't want a fraction here. So to eliminate this fraction, I'm going to just multiply throughout the equation by the denominator. They multiply, and I really don't want my a term to be negative. We want it to be a positive value. So instead of just multiplying by the denominator, I multiply by -5. So multiply by -5 throughout. -5 times -2/5 leaves me with a positive 2x. -5 times a positive 1y is -5y, and a -5 times 14 is -7. So now it's written in standard form. What is my value for A? It is 2. What is my value for B? -5. Include that sign in front of it. What's my value for C? -70. We can check. We are correct. And now let's keep moving. Linear equations in slope-intercept form. We know that in slope-intercept form, it needs to be in the format y equals mx plus b. And immediately that tells me the steepness of my graph, and it tells me where my line crosses the y-axis. So let's look at this. It says tap on each button to learn more. So let's look at our M. Our slope is rise over run. Rise over run. Our slope in this equation is the m in front of it. So our rise here is rising 2. My run is 3. I run over 3 units. I rise up 2, run over 3. So that is my slope. That goes in place of my m. My y-intercept is here at 0, 1. So that tells me this value for b is equal to 1. So then I can write the equation y equals m, which is 2/3, x, so y equals 2/3 x plus b, which is 1. Y equals 2/3 x plus 1. So let's try to write our own. Write 12x minus 4y equals 24 in slope-intercept form. Identify the slope m and the y-intercept b. So we can see that we want to get y all by itself. We want it to be y equals mx plus b. So we've got to take this 12 and move it to the other side. So to get rid of it from this side, I have to subtract 12x. So I also have to then come to the other side and subtract 12x. 12x, take away 12x, leaves me with nothing. So then I just drop down my negative 4y. Negative 12x on the other side and a positive 24. Cannot combine those. One has an x and one does not. And then now what I'm going to do is divide everything by negative 4. When I divide everything by negative 4, I end up with a slope of 3 over 1, or 3, and a y-intercept of negative 6. Again, we can check our answers. They are correct. Example number 3. So we're going to interpret an equation that's in slope-intercept form. So it says shoes. The equation 3,246x minus 2y equals negative 152,722 can be used to estimate shoe sales in Europe from 2010 to 2015, where x is the number of years after 2010 and y is the revenue in millions of dollars. So we want to rewrite the equation so that it's in slope-intercept form. So I'm going to take this x term, move it to the other side. It becomes a negative. Then I divide everything by the negative 2 to get y all by itself. And now I have positives. That's nice. So let's interpret it then in the context of this problem. Remember, it says x is the number of years after 2010. So we've got 1,623x plus the millions of dollars. So if I want to interpret that, the parameter 1,623 represents the rate at which the sales are increasing each year since 2010. Thus, the sales increased by how much? Let's see, what was our number again? 1,623 million each year. 1,623 million each year. This parameter represents the sales in year 0, which is in our case 2010. Thus, because x represents the number of years after 2010, sales were 76,361 million in 2010. All right, moving along. Number 4, using a linear equation in slope-intercept form. Smartphones. In 2013, there was 1.3 billion smartphone users worldwide. Ooh, it's a lot. By 2017, there were 2.3 billion smartphone users. Write and use an equation to estimate the number of users in 2025. So what we need to look at is how many years passed and how many billions that it increased by. So step 1, we need to define our variables. Because we want to estimate the number of users in 2025, we need to write an equation that represents the number of smartphone users y after x years. So y represents how many users, x represents the number of years that have passed. So we're going to let x be the number of years after 2013 and y be the number of billions of smartphone users. So first we need to find our slope, which is exactly what I was doing when I said, look how many years passed and how much it's changed. So we're going to look at 0, comma, 1.31. That shows that in 2013, since that's our starting year that we're looking at, is our 0, there was 1.31 billion. 4 years later, in 2017, there was 2.38 billion. So we're going to complete the formula. 2.38 minus 1.31. This is to find our slope. Slope is y2 minus y1 over x2, so that's 4, minus x1, which is 0. Oops, already has the minus. All right, so what is our slope then? I'm going to have to whip out the old handy dandy calculator. Calculate that. Okay, I got 0.2675. 0.2675. And apparently I got that wrong. So I subtracted and I divided by 4. So let me subtract again. 2.38 minus 1.31 is 1.07. Divide that by 4. And I got 0.2675 again. Guess they wanted us to round. Oh, got to read the directions. Round to the nearest hundredth. Go figure. Now let's check our answer. So it's 0.27. So the number of smartphone users is increasing at a rate of 0.27 billion per year. Ooh, that's a lot. So, little study tip. Remember that rate of change is how a quantity is changing with respect to another quantity. So in this case, we were comparing how much time had passed to the amount of users, how much the users are increasing by. So we're talking about two quantities. We're comparing them when I'm looking at rate of change. Okay, my next thing is to find the y-intercept. Well, that's when x is 0. So when we started off in year 2013, there was what was it, 1.31 billion people using. So that is our y-intercept because that's our starting time at time 0. Now we can write an equation using our slope, using our y-intercept, 0.27 billion people times x, plus the original amount, which is 1.31 billion, gives us our equation then to find after however many x number of years, how many billions there are. Again, a little study tip. Assuming that the rate at which the number of smartphone users increasing is constant allows us to represent the situation using a linear equation. While the rate at which the number of smartphone uses may vary each year, using a constant rate gives us a reasonable equation. This is not going to say for sure that in 2025 there is this many billion people doing it. This is just giving us a way to estimate, to give a prediction, basically, to estimate future data. So now we need to do that estimation. 2025 is 12 years after 2013. So I'm going to plug in my 12 in place of my x. I'm going to calculate it. So we're assuming that there will be 4.55 billion users. If it continues to increase at the same rate, there will be approximately 4.55 billion users in 2025. All right, now point slope form. Point slope form is fun. Point slope form gives us the coordinates of a point and the slope, hence the name point slope form. So it's y minus the y coordinate of that point equals the slope times x minus the x coordinate of the given point, where m is the slope and x1, y1 are the coordinates of a point on the line. So we've got this equation down here. Y minus 3 equals 2 times x minus 8. My slope is 2, and the point on the graph would be x, which is 8, comma y, which is 3. And usually we always look at the side that's in front of it, but notice the minus is a part of my formula. Y minus the y coordinate, x minus the y coordinate. If this was a positive, then we know to change from a minus, we must have had minus a negative to make it be a positive. Therefore, in that case, it would have been a negative 8. If this said x plus 8, then my point would be negative 8. Again, that's because minus a negative is a positive. So in order for this to change from a minus to a plus, my value must have been negative 8. Okay. Point slope form, given the slope and given a point. To me, this is so easy. And I'm sure to you, you'll feel the same way. So we take the line that passes through the point 3, negative 5. It has a slope of 11, and we're going to put it in point slope form. So this y coordinate is negative 5. Remember, it's y minus the y coordinate. So therefore, this minus and negative becomes a positive 5, just like what I was explaining in the previous slide. My slope is 11. Plug that in. And then x minus the x-coordinate. My x-coordinate's a positive 3, so x minus 3. So now I have my equation in point-slope form. We could take this same equation and rewrite it in standard form. We could distribute that, then move this 11 over, then move the 5 over, and we would have it in standard form. We could put it in slope-intercept form, again, distribute, and then move the 5 over so that I had y by itself, but it asked me to write it in point-slope form, so we are done with that one. And example 6. Write an equation of a line that passes through 1, 1 and 7, 13 in point-slope form. Well, in order to write something in point-slope form, we not only need a point, we also need the slope. We don't have a slope, and we have 2 points. So we can pick and choose which one that we want to use for our point when we plug it into point-slope form. But thankfully, they gave us 2 points because now I can use that to find the slope of my line. y2 minus y1 over x2 minus x1 is going to help me calculate my slope. And my slope is 12 over 6, which is 2. So now we know our slope. Our slope is 2. We're that much closer. Pick one of the given points. Looks like they picked 1, 1. Obviously, because I would pick that too. It's smaller numbers. We don't have to deal with such big numbers. So 1, 1, we plug it in, and we're done. If we wanted to put it in slope-intercept form and we wanted to put it in standard form, we would have to distribute and move things around, but we could do that. But once again, it only asks us to put it in point-slope form. All right, and now we're going to write and interpret a linear equation in point-slope form. The Tower of Pisa began tilting during its construction in 1178 and continued to move until a restoration effort reduced the lean and stabilized the structure. The Tower of Pisa leaned 5.4 meters in 1993 compared to a lean of just 1.4 meters in 1350. Write an equation in point-slope form that represents the lean y in meters of the Tower of Pisa x years after the construction in 1178. Okay, so let's look at this. Find the slope. How are we going to find the slope? Well, the tower was leaning 1.4 meters in 1350, which was blank years after 1178. How many years later was that? So let's calculate by subtracting. 1350 minus 1178 is 172 years later. The tower was leaning 5.4 meters in 1993, which was how many years later? So again, we've got 1993 minus 1178. That was 815 years later. Quite started leaning 4 more meters 815 years later. Oops, I didn't mean to do that. Sorry. Okay, so next part says complete the formula using the points 172, 1.4 and 815, 5.4 to find the slope. So change in y, so minus 1.4, over change in x. Let's see here, what's my change in x? So it went from 815 to 172. Actually, went the other way, but okay, so I did change in y, y2 minus y1 over x2 minus x1. Let's go ahead and calculate, and we'll follow the directions this time and round to the nearest thousandth. So 5.4 minus 1.4, which is 4. I didn't need to punch that in the calculator. Minus 815 minus 172, or divided by 815 minus 172. Is 0.0062. So if I want to round to the nearest hundredth, that would be 0.006. To the nearest thousandth, if I did the hundredth, I'd have to do 1. But we did to the nearest thousandth, so it'd be 6. And then, so the lean of the Tower of Pisa increased at a rate of 0.006 meter per year. Okay, so now we want to write an equation. Now that we know the slope, we can grab one of those points, either one that we want. They chose 172, 1.4, plugged it in, and now we have an equation in point slope form. All right, so exit ticket. I'm going to post this on here. You guys can try it, and then I'm going to post the answers. So obviously you need to pause it, try it, and then check your work. And that is all that I have for today. I just about clicked that little X. That would have been bad. I will see you guys next time.